This is the instrument we are going to use in this experiment, and as you can see, this instrument consists of two plastic balls. These two balls and these two balls will represent two charges. You are going to put charges on them, and they will affect each other by repulsive force, since we are going to use the same sign charge, and the distance between the two walls can be measured here from this ruler. This sphere is able to move back to increase the distance between the two poles, and forward to decrease the distance between the two poles. And the distance is something we can read from this ruler. The distance by the way is measured between the two centers. So the distance is now 9 centimeters between the center of the first pole and this is the second pole. Before starting the experiment, that measure the angle should be at 0, and this moving sphere, now by repulsion, one of the two spheres, which is the one we will repelled away, and it will rotate like this, and when the force of repulsion is larger, the sphere will rotate more and more with a larger angle. And to measure the force, we will measure the angle of rotation as such that the angle is proportional to the force. So we are not going to measure force in the newtons, we are going to measure angles in the degrees, since the angle represents the force. And at the beginning of the experiment, you can see here at this point there are two black lines. When there is no force, these two black lines must be fixed like this, opposite each other. Now, how to charge these two spheres? We have the power supply. This one is connected from the positive terminal. With this positive, we can charge the sphere, and for safety, the negative terminal here from the back should be connected to ground or any metal. So I will connect this with this, for example, key, just to be grounded. Now this power supply, when turned on like this, it can supply voltage up to 6 kilowatts. As you can see, the minimum voltage of course is 0, and we can increase the voltage up to 6 kilovolts. This is 1 kilovolt to there is kilowatts, 5, 4, 5, and so on. So this head is now like this. At this position is 6 kilovolts. So when it touches the ball, will be charged with the 6 kilovolts. Now, as I told you in the introduction, this experiment consists of two parts. In the first part, we will fix the voltage. So I will use a fixed voltage of 6 kilovolts as I showed you. Then I charge the sphere by just touching like this. So I catch the sphere. Now this sphere is charged with the 6 kilowatts. Then I touch the other sphere again to charge this sphere. Now this is bigger problem because this is here will keep moving. Okay, now we are ready for the first reading. I adjust the distance between the two spheres to be 20 centimeters, as you can see here, and because they both carry positive charge at 6 kilovolts. This ball, the moving ball, this one is rotated to the left, and we need to measure the angle of rotation rotation. As you can see here, it is rotated from the 0 location. Now, how can I measure this angle of rotation? I can use this one and move it back like this. Okay, until the sphere goes back to its 0 location, and I can measure the angle easily like this. Now it can back to the 0 location and the angle is 5 degrees. Okay, now for the next reading, I will move this ball to a distance of 14 centimeters, and by doing this, I notice that this sphere is rotated again, and it is again not at the 0 location. There's again to the left, and to move it back, I must rotate this to measure the angle more until it comes back with 0, which means the angle was a little bit more than 10 degrees. So all what I have to do now is to repeat this procedure by charging the distance again and again and again. We will use a distance of 10 centimeters, measure the angle rotation again, then 8 centimeters, measure the end of addition again, then 6, then 5, until I finish the readings for this part. And finally, after doing this experiment, I come to this find results for this part. So at 20 centimeters distance, the angle was 5. At 14, it is 10.2. I think it is 20. At 31, at 6 centimeters, the angle was 55 degrees, and at 5 centimeters, the angle was 80 degrees. Notice that the distance are in centimeters, and that whenever you increase the distance, the force becomes larger, which makes the angle more and more. In this part, we will study the relation between the force on the charge, one of the two charges. So we will fix the charge of one of them, which is this moving ball. We will fix it is charged at 6 kilowatts from the first part, but we will change the voltage of the second one. So this second pole, first I will touch to this charge. Now it carries no charge at all, and I will charge this pole at 2 kilovolt. As you can see here, I will take the pointer, touch the sphere like this. Okay, now the sphere is charged with the 2 kilovolts, which causes this other sphere to be repelled away. As you can see, the two black lines here. Now to move it back to its 0, I must use this one right back like this. Okay, until this sphere comes back to its original locations here, from which I can see that the rotating angles was 6 degrees. Now to take next reading, I must increase the voltage to their kilowatts. Touch the sphere again to increase its potential from 2 to 3, but we do not touch the others here because we want its charge to be fixed at 6 kilovolts. Now by increasing this, I notice that there's small repulsion, and this moving sphere is now moved a little bit from 0. The 0